So I'm gonna go over 3 problems on your homework assignment real quick. I extended the deadline to tomorrow night so that y'all can have plenty of time to work on this, and you have 4 chances to redo this assignment instead of 2. So my Mobi is not working, so I'm having to write this on my computer with the mouse pad. My handwriting is going to be horrible, but it's better than nothing. So bear with me while I try to figure this out using the little mouse pad because it is difficult writing on that instead of having my little Mobi thing that I can write on. Okay, and I have a sore throat, so I'm sorry that I keep having to kind of cough. On this first one, it says consider triangle ABC in the figure below. The perpendicular bisectors of its sides are DG, EG, and FG. So I'm going to stop right there. The main thing to figure out these problems is you have to know your definitions. So perpendicular bisector, it forms a right angle, and also what you're going to know is that these sides are going to be congruent. So, man, this is horrible. I'm really sorry, guys. So these two pieces are congruent. These two pieces are congruent, and your other perpendicular bisector over here, let me zoom this in a little bit, these pieces over here are going to be congruent. Oh, man. Okay. And so we also know it says they meet at that single point G. G is the circumcenter of triangle ABC. If you don't know these vocabulary words very well, in your textbook, if you go to page right here, 339, this is really, really good. Here's 6 definitions, and they give you pictures. So here for your circumcenter, it tells you P is that of triangle ABC. It's equidistant from each vertex. So from your vertex to that point, vertex to that point, vertex to the point, these 3 pieces are going to be congruent. So in my picture, and I'll change colors to help y'all out, from your vertex to the point, and I'm going to still do 1. Notice blue and red, even though I'm doing 1 and 1 dash, those 2 pieces are not congruent. Okay, blue is a completely different color. I just don't want to have to do 6 little dashes on here. So what we know is that these pieces here, okay, are congruent. All right, so now let's go to the problem. Let me change my color again. So it tells you, suppose EG is 40. Okay, so that's this piece right here. So this is 40. Oh my dear goodness. Do not judge how bad this is. Okay, there's EG's 40. AB is 82, so that's from here all the way over. This right here is 82. 82. Okay, and then AG, so here's AG, this is 104. Alright, and so now what we're going to do is we're going to find these following links. So, AF, okay, so that's this piece right here. Well, if you notice, these 2 pieces are the same. So if I were to call this X, okay, then I know this over here is X. So what I know is that this piece plus this piece gives me the whole thing. Part plus part equals whole. So X plus X equals 82. So we'll have 2X is equal to 82. This is so difficult and so ugly. I'm so sorry that my Mobi does not want to work the one night that I'm trying to get this done. Okay, so when you divide both sides by 2, you'll end up getting that X is equal to 41. Okay, so what that means is that this will be 41, and this piece up here will be 41. Okay, so here AF is going to equal to 41. All right, next one is BE. I'm going to save that one for last. This one here, CG, that one's pretty easy because if you look, CG has 1 dash on it. And my 1 dash over here is 104. All those pieces are congruent, so CG is going to be 104. And then this last one, BE, let me change my colors again. Do like, what do I want to do? I don't even know what color I want to do. We'll go back over here. Let's do that color. Okay. BE is this piece right here, okay? Well, notice you have a right angle, you have a right triangle, you have 40, and you know this piece right here was your 104. 104. So you can use Pythagorean theorem, and this is going to be so ugly. I know it is. A squared plus B squared equals C squared. Oh my goodness. Okay, B squared that's a squared, is equal to C squared. It's better than nothing. Okay, so now across your 90 is your C, that's 104, so here's 104 squared. Okay, and it doesn't matter which one you want to label A and B. That's just one of your sides, and that's 40. So I can have 40 plus b squared, 40 squared, sorry, plus b squared is equal to 104 squared. So you can do your Pythagorean theorem, figure out what B is. Once you find B, that is the length for BE, which will be your answer here. Okay, so again, these are your perpendicular bisectors. There's a couple more in your homeworks. I'm going to skip over, let's see, another perpendicular bisector. So this one's just like that first one. Okay, so now these are angle bisectors. Okay, so for this one, it says the angle bisectors of triangle EFG are ES, FS, and GS. They meet at a single point S. Tells you here, in other words, S is the incenter. So again, if you don't know your vocabulary, there's a lot of vocab in this chapter you have to know. If you don't know it, this right here is a really good reference. So again, it's page 339. It tells you, what am I looking for again? That's what happens whenever you have a baby and you don't sleep. The incenter. Okay. So here's your incenter. So here's an example. Incenter of Q of triangle ABC is equidistant from each side of the triangle. So for your incenter, it's not from the vertex, it's coming from the side. So all these pieces here are congruent. So looking at my picture right now, it's from your side. All these pieces here coming from the side, all these pieces here are congruent. Angle bisector, okay? Over here, angle bisector, it just splits these two pieces into congruent pieces. So over here, I can change my color. Okay, I know this piece is congruent to this piece. I know this piece here is congruent to this piece here. Okay, and these are supposed to be little half circles, but they're not. They're very ugly, but you all know what I'm trying to do. All right, and now it says suppose PS is 16. So I'm going to just go red. PS is 16. So what I'm going to do right now is I'm going to fill in 16 for all these other pieces because they're all congruent. That's how important it is to know your definitions. ES, that's this little piece, is 21. Okay. Measure of angle PER. So PER, that's this whole thing. So I'm going to change my color here. This whole thing right here. Okay, PER. So that whole thing is 92. And measure of angle RGS. So RGS, that's just one piece, is 18. So right now, if that's 18, I know this right here is going to be 18. And I can't even do this. Okay. So now let's look at what we're asking for. Measure of angle RGQ. So RGQ. That's this whole thing. All you have to do, and I'm not going to work all this out. I'm just going to help you out. RGQ, all you have to do is add these two pieces up. 18 plus 18. Okay, measure of angle QFS. So QFS is this one right here. Now here's where you have to look at the bigger picture, okay? So you have the big triangle. You have 92 degrees here. You have whatever you get when you do 18 plus 18. You can add those up, subtract it from 180, and that's going to give you what this whole piece has to be. Well, it says the measuring angle QFS, so that's this angle right in here, okay? QFS is that angle right in there. So once you figure out this whole piece, all you have to do is divide it by 2, and you'll have the measure of angle QFS. All right? Last one says QS. Well, we already got that. Here's your QS. Okay, and that's how you do the ones for your angle bisectors. And if I talk too fast, pause it, go back, watch it again, and listen again on how to do those. This is just definitions. That chart will help you. There's another angle bisector. Okay, the last one I'm going to do here are your medians. All right, so for the medians, this is the one where you have your shortcut, and it's really good if you know how to do the shortcut. So if you look over here, it talks about your medians. You can also go back a couple pages, and it talks about how it's your 2/3, right here, your centroid. And it's 2/3 of the distance from each vertex to the midpoint of the opposite side. Instead of having to deal with fractions, you can use this shortcut. And I'll show you how to do this. This is really, really not that hard. Because, here it is, centroid of triangle TUV. And there was your definition of your centroid. So again, this is a really good reference. And you'll need to know those definitions for your test. All right, so we have UZ is 8. So I'll go ahead and do UZ. This one is 8. And I'm going to stop right here. So for this one, okay, you have a short piece, you have a longer piece, and you have the whole thing. So your shortcut, okay, I have 1x, I have 2x, and I have 3x. This is, oh my dear goodness, just horrible. Okay. So 1x is your small piece, and I can call that yz. You probably can hear Burnham crying in the background because it's getting close to nighttime and our fussy times right now. So I apologize for that distraction if y'all can hear that. The next one is your middle piece. Okay, that's the longer one. That's your UZ. And then the 3x, that's the whole thing. So that's going to be my YU or UY. I don't care. It doesn't matter which letter you put first. Okay, so UZ, that is this middle one. That's 8. So your shortcut is, okay, 2x equals 8. If 2x equals 8, then x is equal to 4. You just divide it by 2. 3x, well, is going to be 3 times 4, and that's 12. Okay, so you already have all pieces right here filled out, and that's going to help you answer these questions down here. All right, and you're just going to do the same exact thing. So VW is this whole thing. So this whole thing here, yeah, VW, okay, is 33. Oh boy. Okay, so I have 1x, I have 2x, and I have 3x, 2x, and 3x. And so 1x is your smallest piece, that's WZ. So WZ. Okay, 2x is the longer piece, so that's ZV. So ZV, and 3x is your whole thing, so that's WV. So WV. Okay, 3x WV, that's 33. So if 3x is equal to 33, x is equal to 11. So then 2 times 11 would give you 22. And that's all that you have to do. You have one more on here, your ZX. So ZX is 5. Okay, I'm not going to write this one out because this is your homework. I'm just going to help you with it. But that's a 5, even though it does not look like it. So again, you'll do your 1x, 2x, 3x, and this right here is your 1x. And so then to figure out these pieces, you times it by 2, and the whole thing, you times it by 3. And that will help you answer these questions down here. All right, so if you look at the rest of your homework, there's another angle bisector we already did. There's another median we've already done, another median we've already done, and your perpendicular bisectors we've already done. So all these other problems are just like what we did. So if you look at those 3, look at what we were talking about, you use this as an example, watch this video more than once. Hopefully that helps you with your homework. So like I said, your homework's extended till tomorrow night, and you have 4 chances to do this homework. It's going to take whatever the highest grade is. So hopefully this helps. Miss you guys. And y'all keep being good.